Hey, it's great to see someone eager to learn about to-do lists in Python. So, let's talk about what they are and why they're so useful, especially if you are just stepping into the IT field. Imagine a grid where each square can hold a different piece of information. That's essentially what a to-do list is. It's like an Excel spreadsheet stored in code. You've probably come across to-do lists when dealing with grids or tabular data, right? They're everywhere in data processing tasks. Let me break it down to you. It's quite simple but very powerful. First things first, let's understand how they work. A to-do list is just a list within a list. Think of it as having rows of data where each row could represent a record in a database, each containing its own set of columns or values. This model is essential in representing data with a clear structure. Python size is equal to 4 grid is equal to for underscore in range. We've just made a two-dimensional list where every cell starts at 0. We've set up a square grid, and now you can think about what kind of information you could store in a different grid, like maybe player positions in a board game or sensor readings in an IoT setup. Now, accessing an element in a to-do list is done by specifying the row and the column. Here's how Python cell_value is equal to grid hash get the value at the second row and third column, which is 0. In our simple case, it's important to remember the index starts at 0. So if you wanted to fill our grid with ones instead of zeros, and then retrieve the number in the third row and fourth column, it would look like this. Python grid is equal to for underscore in range, cell_value is equal to grid hash accessing the number at the third row and fourth column. You see how straightforward that is? Cool, right? But Python's to-do lists go beyond just storing and accessing data. They allow for sophisticated operations like sorting, appending data, or even transposing them. Transposing, for the uninitiated, means flipping row and column indices. It's pretty handy when working with to-do lists, transforming them and operating on rows and columns interchangeably. Let's see how to get the transpose of our grid. Python transposed_grid is equal to for j in range, for I in range. This code might look a bit cryptic initially, but essentially, it swaps rows with columns for us. Moving on to loops. Loops are perfect for working with to-do lists when you are, say, processing grid data based on certain conditions, or performing operations like summing up a column or row, or even replacing values based on criteria. With nested loops, we can work on individual elements. A simple sum example of all cells except those that are zeros would look like this. Python total is equal to sum for column in range if grid is equal to 0. Wrapping it up, to-do lists are incredibly convenient for various applications beyond basic data storage, like handling matrices in linear algebra, graphing coordinates, or even implementing convolutional neural networks stages like a feature map in a CNN layer. To ensure the skills stay fresh, let's write a short program where we can interact with to-do lists. We'll create a grid, fill it with random numbers, then ask the user which cell they want to check and display its value. Try this out after we finish talking. Python import random size is equal to 3 number. Define the size of our grid. Grid is equal to for underscore in range. Row is equal to grid dot append row underscore index is equal to int. Column underscore index is equal to int. Print. Hopefully, this has given you a solid grasp of what to-do lists in Python are, how they work, and how you can manipulate and retrieve data from them easily. Always remember, practice makes perfect, so keep iterating on examples like these to strengthen your understanding and skills. There's a wealth of knowledge where I have to share it with you without the need for formal guides or tutorials. I'm giving you the insights straight to your mind, and as you understand, you'll have the knowledge to tackle more advanced Python topics. Explore more about data structures, algorithms, and maybe even start implementing some yourself from scratch. They're the essence of becoming great at coding, after all. And remember to immerse yourself even deeper into Python and its applications. You've got to dive into a lot of code, run experiments, and embrace a lot of different scenarios. It's not just about reading about or watching videos of to-do lists. Applying them in projects, solving problems, is where you'll truly learn. That's when you'll recognize the patterns, understand the importance, and see the impact firsthand. So as you keep exploring and learning, always reflect on how coding empowers you, whether you are designing an elegant sorting algorithm for a to-do list, or you are making strategic gains in a game by analyzing game board states. Think about the possibilities. Always ponder on where code can take you, what it solves, and how it unlocks new paths in problem-solving landscapes. And remember, every code you write is another nail in the coffin of frustration for inefficiencies that once bugged you. Alrighty then, keep practicing, asking questions, and stay curious. If I told you that I've got the best resource on Python development right at my fingertips with a simple tap on my website, then make sure to visit and subscribe. There, you'll not just learn, you'll immerse yourself in Python tech culture, get inspired by real-world projects, and tap into a community of passionate coders. Visit neerajdots.io and subscribe for TechLab. Enjoy programming, and don't forget to apply everything we've chatted about today. Cheers to coding smarter, not harder.